Good morning, all of you students. Today we will do another numerical which is based on summer air conditioning. For given input, we want to design a air conditioning system for a auditorium system, for a auditorium hall. Okay, let's start. First of all, you write down this numerical. An air-conditioned auditorium is to be maintained at 27-degree dry bulb temperature and 60% relative humidity. The ambient condition is 40-degree dry bulb and 30-degree wet bulb. The total sensible heat load is 1 lakh kilojoule per hour and total latent heat load is 40,000 kilojoule per hour. Full stop. 60% of return air is circulated and mixed with the 40% of makeup air after the cooling coil. This point is very crucial. 60% used air is recirculated and which is mixed with 40% of fresh air or makeup air. Okay, in order to maintain the quality of oxygen. Otherwise, if we use 100% used air or recirculated air which is coming out of the room, which is very dangerous for human, which leads to suffocation. That is why fresh air is required for any type of air conditioning system. For this type of numerical, 60% of return air or used air is recirculated. That means 40% is released from the room and mixes with the 40% of makeup air. That means 40% of fresh air, which is placed, mixing is placed after the cooling coil. In previous lecture, we have seen that the mixing is done before the cooling coil. This numerical is something different from the previous numerical. This point is crucial. Okay. The condition of air leaving the coil is 18 degree. Okay. Determine the room sensible heat factor, condition of air entering to the auditorium, amount of makeup air, apparatus dew point, bypass factor of cooling coil. Okay. Okay. Now start. First of all, we draw our schematic diagram. First of all, we draw our schematic diagram. This is our first point. This is our second. This is our room. This is the returned air. Okay. Let's mark. This is outside point. This is AC. This is mixing point. This is room or auditorium, whatever you called. Okay. This point is 1. Room is always 2 as per our notation, so that air leaving from the room point is also 2. This is 3. This is 4. Okay. This is our AC. Okay. This is our AC system. Now, first of all, value T1 is 40 degree, TW1 is 30 degree. It is given. Write down all the given data. 2 point is, or inside key point is 27 degree and 60%. 27 degree drivable temperature is to be maintained and 60% relative humidity we given. And this point is also given. The condition in our numerical, please read carefully. In the condition of air leaving the coil is at 18 degree. That is 18 degree. Okay. Now it is told that 60% of return air is recirculated. 60% of return air or 60% of used air is recirculated and mixes with the makeup air or fresh air, which is amount is 40%. Okay, which is placed after the cooling coil. 40% air, which is first conditioned, then mixes with the 60% of recirculated air. Okay, our all point has been written here. This is our numerical, and which is given. Room sensible heat is given 1 lakh kilojoule per hour, and room's latent heat is also given, which is 40,000 kilojoule per hour. This is also given. Okay. First of all, we determine the room sensible heat factor. That means RSHF equals to room sensible heat by room sensible heat plus room latent heat, or room sensible heat by room total heat, which is, this is 1 lakh by 1 lakh plus 40,000 means 1 lakh 40,000, which is 0.71. This is our first answer. Okay, this is room sensible heat factor line. Room sensible heat. Okay. Now erase all these things. Now we are going to draw all the processes, all of this happening for this system in our psychometry.